Hello guys, in this video we're gonna try to break things, but before doing that I just want to recap what happened in the meanwhile so far. So we saw this schema I just draw a little bit better, where we seeing different functions such as the simple projection, the solver pole vector being put inside another function, so either solver ik or solver fk. These two functions become the core part of the solver ikfk, and then in the end yesterday we implemented a little bit of foot rig functionality, and all of that we call module leg. Now the same thing we can do to create the module arm. It's a little bit simpler, and the reason being, we're going to see that in a minute, is because these two functions are identical. You can see that these two are exactly the same. Let me change color. These two here are exactly the same. And then I simply added the solver hand that we already did in one of the videos about the arm, and then put those two together and call it module arm. After that, in the main rig graph, we simply have a function that that colors the control based on the label _L, _R, or yellow or green, that kind of stuff. We saw it yesterday, or a couple of videos ago. Now I don't remember. Okay, let's jump into Unreal and see how that looks in Unreal. So this is the rig graph, and it's the highest level, and you can see that the graph is starting to becoming more and more. The functionalities are more than we had before, because we have arms and legs, but the graph does not get that complicated, and it's almost kind of a linear reading from left to right. And let's have a look at what's going on here. In the setup event, I simply set in the colors based on the labels. So everything that is of type control _L will get this color, and so on and so on. So I never set this color manually, and you can change these, of course, with whatever you want. And then what we have is simply, I have two arms, so I have two module arms, I have two legs, and I have two module legs. And the only difference between this and that is just one uses the bones and the controls _L, and the bones and the controls _R. Same goes for the legs. So if you want, you can look at this. If this is the arm, this is the arm, this is the leg, this is the leg. Eventually there will be a head and a body, and here you have your visual graph as a biped. I don't find that very easily readable, but that's something you can do if it helps at least understand how the structure works. So this is the setup event, and because we are in the setup event, we are in setup mode. Then once we did this, I simply duplicated them, moved them down, and removed the setup event. Everything else is identical. Module arm, module leg, module leg. What's happening here? This is simply, we have 4 controls to define IK/FK for each limb, so arm, leg, leg, and based on that is flopping the visibility of the controls. We went through this. Let's have a quick look into the module arm. The module arm is very, very simple, because it's a solver IK/FK, as we saw here. Solver IK/FK, so I just had to copy and paste the solver IK/FK from my solvers, drag and drop. And then on top of that, I added the solver hand, which is something that we built last time, which is simply, it's a very simple solver which connects each bone and its child to each control and its child. So, and it's leveraging the function that we saw called connect via children. I think I wrote that down here. Yes, there it is. Okay. So you can see that in the end, writing the module of the arm, the final module of the arm, was really simple. I just simply added this in setup mode, and the same thing not in setup mode. So this will be used in the setup event, and this will be used in the forward solve. So that's pretty much it. And now we have arms and legs that do behave, hopefully. Yeah, they do behave. We have everything. I turn on stretching just because. So we have now solvers, utilities, and modules. So here's where the high-level functions, or the smart node graphs, will appear. And you can see that because I have a module leg and a module arm, I can have many of those. If I have four legs or 4 arms, they don't necessarily need to be in front or on the side. They can be anywhere. There could be a 3rd leg. So in this way, if you have a character that has a leg or an arm in some weird places, you can just simply substitute these values, rather than pure mirroring. You can do mirror, of course. Mirror is always cool, but also just by changing the names here, you can put the arm whenever you want. For example, that's just an example. So okay, so why did we go through all of this, like all these videos, just to oh, by the way, cool trick, Shift D aligns the nodes vertically. It's the same controls for the blueprints, and Shift S aligns the nodes horizontally. Anyway, so like for example here, I want these to be nice and laid out. This guy, great. So why did we go through all of this? All these videos to encapsulate and making sure that these values are exposed, and making sure that with just one node we can build a complex mechanism. Well, the reason is, I'm going to try it now. The reason is, so far I've been using this skeleton, which I don't remember where it came from, to be honest, and I've been building my my simple geometry around it, this little thing. And the reason why the geometry is so simple is because it helped me out understand the orientation and how things works in control rig. Well, I think it's about time that we start moving into a more interesting geometry. So if the whole system worked, I should be able to swap the skeleton with a completely random one. I'm going to use a biped, of course, because this is what we're looking for right now. And everything should still work when we change the names of the bones. So what I'm going to do is simply go here. I logged into Mixamo, and I'm going to pick like this one. I want to have, I guess this is, yeah, I want to download this character, Mixamo, completely random. Oh, hi guys, sorry, I was kicked out from the website for inactivity. I had it prepared, but then it kicked me out. So I logged in back again. I paused the video just to enter the details. Yeah, I downloaded this guy. I don't care about the animation or anything, just care about the skeleton. So let's import it. So let me create a new folder called Mixamo, and let's import in downloads taunt. Great. I want the skeletal mesh. I don't want any animation. I want to create new materials. Fine. This should come in with the materials described in the FBX, and this should be our skeletal mesh. Oh, brilliant. Okay, so just to double check everything is connected. Yes, it looks like it went through fine. So now, because Unreal doesn't allow us to store what we made as solvers into an external node, an external asset like control rig functions, like it does with blueprints, like the function library or the macro library, I guess that's coming. For now, I just have to copy this control rig into the Mixamo folder. Come on, let me grab this asset, mixamo, copy here. Okay, so it did copy it, and now let's open it. Cool. So now I have this new. It's just a copy of the control rig. The first thing I want to do, well, I want to turn off auto compile, and then what I want to do is basically, I still have all my controls here. Basically, substitute this hierarchy, which has been imported previously, with a new hierarchy. So let me detach everything first, so we can build the things. And let me get rid of the root hierarchy. Great. So the hierarchy has been removed, and now I'm gonna import the new one. Guess is taunt. Okay. It's importing the new hierarchy. Great. And as you can see, it's a completely different skeleton. And the idea here is that we need to substitute the names in here with the new names that comes with the skeleton and the new orientation. Another thing that we want to do is change the skeletal mesh preview with the actual one. Okay, you can see that is a completely different skeleton, a completely different proportions, and let's see if all of this does work. Because I detached all the color, these went back to the original color. I was setting them manually originally. But now through this control here, you can see that this is taking care of shading the controls in a specific way. So let's show the bones. It's not showing the bones, probably because I have to do refresh. Boom, and we have the bones. So great. So now we can start. The first thing I want to do is slowly, bit by bit, let's remove all of that. Yeah, I don't want the forward solve. Let's analyze it bit by bit. So the first thing I'm noticing is that, you know, some of the stuff went into place. Maybe there's some bone matching, but at least the colors are fine now because I connected this bone again. And now we're going to start with the module arm. A bit of observation here. The module arm is oriented along the x-axis, and the pull vectors is along the z. That is important. So let me find the names of the bones and let's start substituting. Upper bone is, in this case, I guess is left arm. The lower arm is left for arm. I am constantly looking here. Basically, I'm copying these names here. And left hand. The controls, I don't need to change them because it's still my names. So, and then I need to do the bones for the hands. And the hand bone is left hand. The hand space is still that one. The thumb bone is left hand thumb 1. The index is left hand index 1, and so on. Middle. Ring. So it seems like everything has been connected properly. So what I expect here to happen, if everything has worked, is for the controls to pop into the right place, because we're only running the setup event. Let's compile that. I turn off auto compile, and you can see that instantly the controls have popped into the right place. Now bear in mind that this does not absolutely nothing right now, because this is just a setup event, but at least we know that the controls are in the right place. Now let's get rid of this, and let's duplicate this because it's pretty much the same. And now I'm gonna change left with right, 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 right. Here I need to change with R, of course. R. These are my controls, but I need to switch them to change the. So you can speed up the video because this is gonna take some time. So right hand and right hand thumb. It's gonna be R. Right. R. Right. R. Right. This is where a nice procedure to rename things will be nice. Maybe that's coming. Let's connect it. Let's compile again. And oh, this is the right arm, so something I may have to change a few things, but overall, yeah, I can tell that something weird is happening here. So we're going to have a look at why this is happening now. So, but you can see that, you know, the controls have popped into the right place. So why is this happening? I wonder if it's because we are, so this is thumb L2 control. It's because of this. I was snapping the wrong thing. I didn't change that. So let's compile that again. I was snapping the hand space to that position. Great. So this is in the right place, so that's good news. I'm doing this live, guys, so bear with me. I said at the beginning of the video we're going to break things. So okay, this has snapped into place, but you can see even if we went through the boring process of changing the names here, this just took 1 minute to adapt a completely different skeleton that could come from a completely different pipeline with our rig, the rig that we've built. Okay, so what we can try now, because I think that is going to break, we can try now, let's remove these two nodes, take these, which have the same name, remove the setup, connect them, and then simply add the control for the switch and the control for the switch. So let's compile that again. I haven't changed the primary and secondary axis for the pull vector, so I expect the pull vector in some cases they should be wrong. So if I select the wrist L control and move it, nothing is happening, and the reason is I haven't attached the forward solve. Yeah, live debugging, fun. Let's compile this again. So the reason why I think it's going to fail around the elbow is because this joint orient are, yes, and it did. This joint orient are different. Something is going on that is not right. I mean, this does work, but and as you can see, this thing, it's already in a very good place, but we need to adjust because we have rigged the fingers pretty much automatically. We snapped all the controls automatically, and the pull vector seems to work, but it does perform a flip at the very beginning, and the reason that's probably because I haven't tweaked the axis. So I compile that again. I'm checking the axis here, and the axis is telling me that in this case I want the X to be there, and I want positive Z, actually negative Z, and in here I want negative X and negative Z. I'm looking through how this bone is oriented. So let's try that. Let's put those values here as well. This was 0, negative 0, negative. Oh, I did not click compile. Come on. By the way, the compilation process, it's a little bit longer, but it won't affect the performances of when you evaluate the rig. So this is just an offline kind of time. So we can see that now the pull vector is in the right place, everything popped back into the right place, and this works. Now let's see if this actually works, or if there's still something that we need to adjust. Let's take the left arm, IK, and we switch to FK, and the FK still works. So I consider this, you know, one of the proof of why I think building the solvers this way, it's much more powerful, because again, I'm not relying on any specific skeleton, and these solvers can now be adapted to any skeleton. So I mean, we can keep going. Let's see if everything here works. Okay, that one, and the switch, and everything should still be there. And let's try to go back here. I'm really trying to break things, but oh, okay, so this seems working. Oh, yeah. So this is happening because I didn't enable the stretching. And so when it comes to the leg, it's pretty much the same thing. So let me, yeah, these are detached. Let me get rid of those. So I'm going to copy the first values here. And now we do the same thing. So, I mean, you can totally speed up the videos. I wouldn't mind. Left up leg, left foot. So, left up. The thing is, like, each studio or each pipeline comes with different naming convention. As humanity, we haven't found the perfect naming convention yet. I don't think we ever will. Bowl, it's, I guess, well, how is this called? It's toe, left toe base, left toe base. Let's do this in the meanwhile as well. Right, I left one key behind. So left leg, right leg, foot, right toe base. The controls are these needs to be R. Oh, I already put the R. Nice. Left, R. We don't have any additional controls. And of course we have to place the offset for the heel, which is basically, you want to put this control there, and this control roughly there. and you can do it by changing these values. I'm not going to do that now. The other thing that we want to check is, again, the pull vector. So here we want the y-axis to be 1. Interesting, this skeleton here has different orientations for the limbs from the arms compared to the legs. And then we want positive z, and then here we want 0. Let's see, I think it's the same, and that should be it. Let's see what happens. It's just the setup mode. So the controls should start popping into place. Of course, I probably made some mistakes along the way, but I wanted, so I understand that this is a bit boring, but I wanted to go through and do it with you guys live, because in case you're trying to debug things, you can see with me, you know, where things can go wrong, because you know things totally go wrong all the time. So the control seems to have popped into the right place. The pull vector solver has done its job. It has computed the right position. So what I can do now is basically take these two nodes and jump into the end of forward solve by removing setup, connecting these two things together, and again I want to make sure that the leg IKFK controls the switch for the left leg, and the right controls the switch for it. And let's compile. I found really interesting that the y-axis is going down along the bone here, while instead of the arm is the x-axis. Something I haven't seen. I wonder why that is. Maybe is the mixamo internal system on how to compute angles and stuff. I'm not sure why. Why is that? Usually, I mean, I guess it doesn't make much difference if it's an FK skeleton, but because it's basically mocap based, I was expecting the axis to be consistent. But again, I don't know enough about mixamo to say why there is a different orientation axis. Okay. Oh, okay, great. I guess you can say something went wrong, and that's actually good. And when this kind of stuff happens, you can see that pretty much the IK is working. But when this kind of stuff happens, and let's see if the foot has been worked. Yeah, you can pivot from different position. So when this stuff happens, it has to do with the primary and secondary axis. This means that something I've put in here is wrong, and you can see it's definitely wrong because I didn't zero out the y. You may think that I did this on purpose, but in this case I really didn't. Sometimes I do things on purpose to break things. In this case I didn't. That was a proper mistake. So hopefully, if this now works and compiled properly, this is basically the end of arm and leg modules. But also it's a video I wanted to make just to show you the reasoning and the thought process behind building nodes this way, because now you have modules that can be adapted to characters almost independently from how the bone structure is. What I mean that by almost is that, you know, a leg needs to be a leg. It needs to have leg bones, and an arm needs to have arm bones. But the more you build your nodes, you know, with a little bit of proceduralism in mind, it's going to take longer. As we saw, it took like 10 videos just to make these, but it's going to pay off in the end. And now you can see that the legs are working fine. So we completely in a matter of minutes. Now keep in mind, if I were to do this without recording, I could have been faster. In a matter of minutes, we reconstructed the rig that we made, that adapted for completely different characters, not with the same bone names, but with a completely different set of bone names, which comes from a different pipeline, for example. I hope you found this video interesting. Let's move on. Bye bye.